Good morning. The coffee's hot. You've found your seats and we're ready for the show. So I'm super excited to see everyone here today. In fact, yesterday we had hundreds of folks coming in already taking advantage of our member day. It was a great opportunity to see old friends, make new friends, engage in a hackathon, try out RISC-V 101, engage in member day activities all the way through. So the energy was already palpable. And so I'm so excited to see you all coming in bright and early. That means the after party didn't go too late last night, and we've got an amazing week ahead. So thank you so much. I'm excited to kick this off for us today and engage with you throughout this week. I'm going to talk to you today about several trends that we see going on in the RISC-V community and around the world as we start to usher in this amazing new chapter. First, I'd like to thank our amazing sponsors. Without sponsors supporting this event, without all of you coming in as well, we would not be able to host these forums each year. So it is an absolute honor to thank Andes Technology, Damo Academy, and Microchip as our diamond sponsors this year. I would also like to extend my thanks to our platinum and gold sponsors as well. Please, if you see them around today, say hi, stop by the booths in the expo hall. They've got amazing progress that they've been making and that we'll be showcasing here this week. I need to thank you. I need to thank more than 16.7 thousand individuals who are signed up in our member mailing list, Slack lines, groups, and other things that are engaged, rolling up their sleeves, hands-on code, getting work done. Thousands of engineers around the world engaging in more than 80 different work groups. By the way, we host like 1,000 meetings a year. We have a lot to do and we're getting a lot done. In fact, so far this year, 21 different extensions. Perhaps you saw the press release yesterday. We've crossed the finish line on RVA 23 and RVB 23. Congratulations. Yeah, the whooping and hollering can begin. So this ecosystem growth that we're seeing is going across all parts of our ecosystem. From operating systems, tools, and applications, we are seeing tremendous growth and adoption. We have launched industry-specific initiatives, both in technical deliverables and in market development. This is a great opportunity to engage in case studies, blogs, showcase your success, showcase how you're pushing the edge of innovation. We have done a lot to infuse and build talent across the industry. So far this year, we have trained more than 9,600 people. Did you know that we have more than 8 courses available in RISC-V? That you can be RISC-V certified as well, and that will help boost your career. When you tie your career to your passion and get a paycheck with that, that's what makes a career matter. And each of your careers is mattering to us. We have tens of thousands have signed up for RISC-V newsletters. Within the first week of our LinkedIn newsletter, we already had 20,000 subscribers, along with more than 100,000 following us on our socials. So this is what represents all these members across our ecosystem around the world in 70 different countries, still about a third in each of the major geographies. But we're not stopping there. We have fundamentally launched the most important new generation in computing that we have seen in decades. This is an amazing time to be in microprocessors. This is an amazing time to push the edge from the smallest, lightest weight to the most performant in data centers and HPC. Here's some fun facts. Fresh off the analyst press from SHD, we estimate 2 billion SoCs. You've heard us talk about cores. We're switching to SoCs. 2 billion SoCs this year, growing to more than 20 billion SoCs in 5 years. This is an amazing growth trajectory for an architecture that was pretty, nascent just a few years ago. We're growing from almost 6% of the market to more than a quarter of the market in that time frame. That is rapid adoption. That is rapid adoption across numerous different industries. And that's because there is technical advantage and there is business advantage. You bring those together and you usher in more than a third of the market across the top 3 of these. By the way, in RISC-V 101 yesterday, I asked if anybody knew what are the top 3 markets for RISC-V. Where are we seeing the most growth? Well, here you have it. In fact, somebody was giving me guesses this morning, wondering if it was this market or that market. I said, no. Here's the answer. More than a third of the market, in fact, 39% in consumer. This includes mobile. More than a third of the market in computing, notebooks, things of that nature. We're seeing this already coming to market. In fact, in our developer zone, you're going to see laptops. Right? We have laptops with RISC-V. This is a new day. This is a new era. In automotive, whether it's infotainment or any of the other components, especially as you start to move into the next frontier of autonomous and assisted driving, you see a lot more customization potential, capability, progress, and adoption already happening. More than 30% already in automotive. Fast on those heels, you find data center, industrial, and networking. So 5G, Wi-Fi infrastructure, IoT manufacturing, data center for acceleration and AI. These frontiers are moving quickly, and RISC-V is central to the growth trajectory in these spaces. So let's talk today about 3 important aspects, 3 important trends. So, we all like the notion of collaboration and co-design. RISC-V makes that real. RISC-V makes the era of workload-defined silicon matter. And then everyone's favorite buzzword these days, AI. With specific algorithms, from training to inference to generative AI, RISC-V is absolutely primed for this opportunity. And then, the trend that we're seeing start to grow with added momentum is the level of investment that we're seeing at nation levels all the way down into local markets that is engaging in the global opportunity. So we'll dig into these a little bit. So let's talk first about workload-defined silicon, also known a little bit as software-hardware co-design, collaboration. If we go back in time, we had mainframes. Large, monolithic infrastructure, critical systems approach to computing. Fast forward into the PC era, specify a limited number of attributes and variables at a system level, off-the-shelf personal systems and components, mass production, kind of a race to cost savings at a system level. Fast forward to SoCs. Limited options, largely proprietary held innovation. You started to need to do more in the application layers, right? Because you're dealing with more homogenized silicon. And that innovation in the software layer kind of left hardware behind for a minute. And now, because RISC-V enables you to design specific to the workload challenge that you face, you're able to do more composable IP, composable designs, co-designed for your workload that you're trying to reach. And that hardware and application-specific co-design is where the world is going. So let's talk a little bit about workload-defined silicon. This means that you profile your workload, identify your challenges, and can design silicon specific to that. Whether you're seeking to move the dial around power, performance, and area, or you're optimizing for scale and other efficiencies in a large data center, perhaps a single workload or multiple, whether you're looking to accelerate your time to market. It doesn't matter if you're a large multinational or if you're a startup looking to enter new territory, new growth opportunities. You want that design freedom. You want design freedom and flexibility to tackle that workload in a way that makes sense to your business. RISC-V affords you that opportunity. At the center, you select RISC-V. You base that instruction set architecture decision on a core standard that everyone around the world is leveraging. Immediately, you have opportunity to do scalable processing, customization, and extensibility, within your own walls, right? You can dial the performance and efficiency advantage that meets your demand. That's where you're doing your hardware and software co-design. But wait, it gets better. As you build out into the larger realm, you start to realize an ecosystem that includes valuable IP, differentiated IP that you can help bring to market, or that you can select from a variety of vendors to help improve your innovation. It means you have tools and design services that work as well on RISC-V as any other architecture. It means that you have portability of software and applications. And this together brings out your opportunity, your innovation. Now, we talk a lot about AI. And AI is all about very specific algorithms that are fine-tuned to specific workloads. When you bring that together with the underlying hardware, there are limitless opportunities for innovation. By bringing an extensible ISA, something that allows you encoding space to deliver your own innovations, you're able to bring RISC-V as the base platform across all components, the GPU, CPU, the NPU. This enables you to build out an entire solution, not just a single chip. That common language is the instruction set architecture. That is what truly delivers the modularity of this platform. So by gluing into that single instruction set architecture with numerous extensions that have been cultivated by this community, you can rest assured that you can pick and choose from various different vendors for your IP. You can accelerate your time to market by engaging in those group dialogues that supercharge your learning and development around the art of the possible. And this brings you to a global community of experts, many of whom are in this room. And it's been such an honor to see the collaboration going on in our communities to bring many of these extensions all the way through to ratification. This gives you control. This gives you control to pick and choose from that menu of extensions, adding in your own unique differentiation. This enables you to have portability across all parts of your stakeholder community. This rapid innovation allows you to get to market faster and likely better, likely with a more competitive solution. And that's the promise of what we've learned in hardware standards over many, many decades. The more you innovate, the more valuable your own IP and your own solutions become. This is not just technically cool. This makes for a stronger business proposition as well. When you can accelerate your time to market, accelerate your innovation cycles through collaboration or just through the model that you've chosen, and you've released yourself from those restrictions of traditional proprietary architectures, this enables you to engage with more development partners, more scalable solution sets that go into adjacent markets, and that continues to grow your business. It's not a one shot and that's it. You have multiple opportunities then for success. Let's talk a little bit about what we're seeing at a global and national level. One of the things that I've talked about as I've given talks around the world is the incredible drive that I see in countries around the world that are investing locally, engaging globally. Brazil is a great example of this. The Ministry of IT, Science, and Technology has invested in RISC-V specifically to spur their digital economy, to engage talent, to engage business opportunity, to further and accelerate research opportunities. This is a role model that we see standing up for countries around the world, right? They're investing locally. But they're investing locally in a manner that opens doors and opportunities globally. That means by building on RISC-V, they aren't constrained to their country alone for development partners, supply chain, market opportunities. This is how you build an economy that lasts, a long-term sustainable strategic position. These are some examples, and you'll see this for Brazil, as well as some other regions that we've pulled out. And this is where you see that collaboration, that public-private partnership, and that engagement across various stakeholders, from universities to research institutes to multinational companies. There is an infusion of excitement. There's an infusion of learning. There's a growth in skills and promise as we see the activity going on in Brazil ignite additional activity in Spain, in Chile, and numerous other countries in the Spanish and Portuguese-speaking world. China has been a long-time proponent of public-private partnerships across many of their institutes, research organizations, as they engage from university students. Remember the one student, one chip initiative, all the way through to their multinationals who are engaging in communities like RISC-V, contributing back things like Android. The first Android write was done by our friends at Alibaba. We see this happening within alliances, regional alliances, where the collaboration is happening, and the giving back to the larger global community is what encourages us all and inspires us all to see that next frontier. Chengwei Capital is on here. That's a venture capital firm, igniting entrepreneurialism in that region on RISC-V. In Europe, the European Union has dedicated a lot of funding to various initiatives, and I know many in this room are involved in these initiatives, right? So it's exciting to see government agencies coming together to spur their digital economy, their next frontier in semiconductor, being part of that economy. So through joint initiatives, we have things like Isolde and Tristan, and the European Processor Initiative, the CHIPS Joint Undertaking. And then this is then spawning even more collaboration, as we've seen with OpenChip and Cantaris, organizations that are coming together specifically around AI or automotive to pool and share and grow that industry. So these are important aspects that we can be modeling after and that we see happening in our community. In the United States, we see a lot of activity continuing in universities, moving many of the early courses over onto RISC-V. RISC-V was born because we wanted an opportunity for students to go from idea to tape out. And we're continuing to see that proliferation in universities. All the way up through agencies. We see agencies like NASA selecting RISC-V for their future. And that is in collaboration with the private sector, with Microchip and Sci-Fi behind that opportunity. We continue to see US companies engaging deeply in RISC-V in both their own products and solutions, as well as in our community. That leadership is something that is fundamentally important to this community, as we see with Google and Qualcomm, organizations like RISE, collaborations across China, US, like RIOS. These are things that are setting the model for generations of compute to come. So RISC-V is fundamentally redefining the next era of computing. We are already there. This is not something that's going to start happening tomorrow. We are on that trajectory already. More than 2 billion SoCs this year to 20 billion SoCs in 2031, 5 years. That's the forecast. And by the way, the only time I've seen these forecasts wrong lately is when they didn't quite set the sights high enough. These forecasts continue to improve. And you'll hear more from the SHD group this week on those. So whether it's the hardware, workload-designed silicon specific to the application and the challenge, whether it's venturing into greenfield opportunities in AI for training, inference, and generative AI opportunities, or bringing that acceleration to a workload in a data center, whether it includes entire countries or regions investing locally and engaging globally. This is our time. Welcome to RISC-V. This is just the beginning. This is your time, and it starts now. Thank you.